What's going on, everybody? Welcome back to another video with Mr. Diamond. And today we're going to be talking about the polyatomic ions. Now, I apologize if this is sounding a little weird. I got my desktop mic that I'm making sure is in a good angle here. So what I'm going to do here is I'm going to talk you through this polyatomic ion sheet. There is a copy of this on Google Classroom. There's also a Quizlet that has all of these in there that you can use to study. But what we're going to go is I'm going to talk through each one of these and try to give you a little bit more background, especially on this side right here. This side is the part that's going to be a lot harder. Hopefully at this point you already have kind of done a little bit of practice and started memorizing these guys over here. If not, definitely go back and start working on that. So to begin, over here we've got formulas. And we've got names, and then we have them separated by their charge. You have to know all three of those things. You need to know the name, the formula, and the charge of all, I believe this is 14 maybe? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 of the polyatomic ions. Now, if we just look at the name, poly means multiple, atomic is atom, ion means something that has a charge. So they are multiple atoms that together have a charge. The whole point and the whole reason they're important is because these things function as a unit. They actually stick together and they don't separate very commonly in chemical reactions. So when you have an ammonium, for example, instead of having to treat it like a nitrogen and 4 hydrogens, we can actually treat it as one big chunk that all together has a +1 charge. And we can take that NH4 and use that in our reactions instead of using like just a single sodium. We can use just a single ammonium. Ammonium is the only positive one that we care about, NH4 with a plus charge. Then we have our -1 polyatomic ions. We have acetate, which is C2H3O2. We have nitrate, which is NO3 with a -1 charge. We have cyanide, which is a CN with a -1 charge. Again, all of these are negative ones. OH is hydroxide with a -1 charge. MnO4 is permanganate with a -1 charge. ClO3 is chlorate with a -1 charge. Then we've got our -2 polyatomics. Sulfate is SO4 with a 2-. Carbonate is CO3 with a 2-. Chromate is CrO4 with a 2-. Dichromate is Cr2O7 with a 2-. Silicate or silicates, because we've been pronouncing all these as 8s. It's SiO3 with a 2-. And then peroxide is a little bit weird. It's O2 with a 2-. Normally oxygen by itself has a -2 charge, but peroxide is a special case. And then down here we have our one -3 polyatomic ion, which is PO4 with a 3-, and that is phosphate. Now, all of that you need to have memorized: names, formulas, and charges. And we're only going to be using them more and more as we go through the year. But there is another whole set of compounds that we can talk about here that takes this list of 14 and turns it into a list of 50 plus compounds that you can have available to you. And the reason that we do that, it's probably not 50 plus, it's just like probably close to 50 though. Say like 40 plus, that's a better number. And that's because if we look over here, we have chlorate. Chlorate is ClO3 with a -1 charge. There is also perchlorate, which is ClO4 with a -1 charge, chlorite, which is ClO2 with a -1 charge, and hypochlorite, which is ClO with a -1 charge. And just like there's with chlorate, sulfate, which is normally an SO4, there's persulfate, which is an SO5 with a -2 charge, sulfite, which is SO3 with a -2 charge, and hyposulfite, which is SO2 with a -2 charge. So what this means is that by changing the prefixes or the suffixes, the beginning or the ending of these words, or sometimes both, we can actually modify the amount of oxygens that are attached to a compound. So if we assume 8 is the base, which for most of these it is, 8 has a certain number of oxygens. You just have to memorize that. Sulfate is 4, for example. Carbonate is 3. Chromate is 4. Chlorate is 3. So some of them are 3, some of them are 4. You just have to know which ones are which. But once you know that, if you memorize this rule, you now know actually 3 other additional compounds just by knowing that one compound. So one that wasn't up here, for example, carbonate. Carbonate, it ends in an 8, and it doesn't have a per out front, so that means that is our base. Carbonate over here has a CO3 charge. And notice that the charge for all of these stayed the same. Sorry, a CO3 is its formula. It has a -2 charge, but all of these charges stayed the same. These were all -1s, these were all -2s. So we're actually going to leave the charge exactly the same for all of these carbonate derivatives, or all of these different forms of carbonate that we're going to look at. They're all going to have a -2 charge. The only difference is going to be per carbonate has one more O than carbonate normally has. So carbonate is CO3 with a 2- charge. Percarbonate would be CO4 with a 2- charge. If we go down to ite, we would actually remove an oxygen from whatever was the base. So carbonate is CO3 with a 2- charge. CO2 with a 2- charge would be carbonite, aka the thing that Han Solo got frozen in. And then if you wanted to go even one step further and remove one more oxygen from it after that, you could have hypoblankite. So in this case, it would be hypocarbonite, and that would be 2 oxygens less than the normal version. Carbonate normally has 3. 2 oxygens less than that would be CO. So CO with a 2- charge would be hypocarbonite. Now, this doesn't work for every single one of them. Things like hydroxide, acetate, I guess you could do it with acetate, but that's not very common. Ammonium and cyanide, you're not really going to do anything with. I will also point out to you that if you look at the endings for all of these, 8,8-ide, 8,8,8,8,8,8-ide, 8. These ones, peroxide, hydroxide, and cyanide, have a little bit of weirdness because of their endings. We'll talk about that a little bit later on in this chapter, but I just want to point that out to you now. Basically, all of these have an ending that is the same, that is 8. Permanganate, notice, is already in this version right here. It's a per blank 8. So if you just wanted a manganate, you would actually do MnO3. Manganite would be MnO2. Hypomanganite would be MnO. Again, with a negative charge each time. Permanganate is just the much more common version, as opposed to most of these where like perchlorate, persulfate, percarbonate are kind of less common or less likely to show up than their non-per prefixed counterparts. The last rule is barely going to show up, but I want to show it to you just in case. You can also use hydrogen as a modifier. You just add a +1 to the charge and put a hydrogen out front for every time that you do it. So phosphate is normally PO4 with a 3-. That's just right here. You could also have hydrogen phosphate. Hydrogen phosphate would literally be if you add an H out front, H's have a +1 charge, or the H will have a +1 charge and affect this -3 into a -2, and HPO4, 2-, that's hydrogen phosphate. Dihydrogen phosphate, di means 2, so dihydrogen phosphate, H2, PO4, but now we have 2 hydrogens that we've added out front, so we're going to drop it by 2, and it would just be a -1 charge. Okay, hopefully that makes a little bit of sense. You really are going to just need a lot of practice. There's a reason I mentioned these at the beginning of the year, even though I assume most of you did not really go back and look at it because, I mentioned at the beginning of the year, you felt like you had plenty of time. These will show up a lot if you plan on having a career in chemistry or biology. Even for a lot of these, you're really going to want to make sure that you feel comfortable with what these polyatomics are. These are the most common ones. There are a ton of other ones other than these, though. So if you're mad you have to memorize 14 of them, I used to have to make my students at Jackson memorize like a good 20 plus of these, and then by the time you hit to like college, you might be having to know 30, 40 of them that could just randomly show up depending on your area of study. Don't quote me on that, though. In the meantime, though, that's all for this video. Hope you have a great rest of your day. This is Mr. Diamond, signing off.